Okay, so we have the example in exponential functions based on integration. So problem number 1, what is the equivalent antiderivative of e to the power z dz over the square root of 1 minus e to the power z? Okay, so I let 1 minus e to the power z is our u. So therefore, u is equals to 1 minus e to the power z. Okay, so where du here, that is equals to negative e to the power z dz. Okay, so don't forget that our derivative of e to the power u is equals to e to the power u du. Okay, so by the way, dz here, okay, that is equals to du over negative e to the power z. Okay, okay, so now we can change the given so that we can integrate. So that is equals to the integral of e to the power z times where dz, that is equals to du over negative a to the power z over the square root of, so I can change this 1 minus e to the power z into u. Okay, so therefore the square root of u, so equals the we can cancel e to the power z, and we have negative du or the integral of du over u to the power 1/2 square root of u is equals to u to the power 1/2. Okay. So we have here integral of the inverse function of u to the power 1/2, that is u to the power negative 1/2. Okay. Then du. So we have the u to the power negative 1/2 plus 1 over negative 1/2 plus 1. Then we have plus c over, okay, so that is equals to the negative u to the power 1/2 over 1/2. So take note that negative 1/2 plus 1 is, that is equivalent to 1/2, then plus c. Okay, so we have negative 2 u to the power 1/2 plus c, then substitute the equivalent of u, which is 1 minus e to the power z. Okay, so we have the quantity of 1 minus e to the power z to the power 1/2. Okay, by the way, this can be 1/2, positive 1/2. Okay, then plus c, or negative 2 square root of 1 minus e to the power z, then plus c. So that is the final answer. Okay. So another problem. Okay. So what is the antiderivative of e to the power 1 over x dx over x squared? Okay. So by the way, I let u here, which is 1 over x. Okay. Then we have x to the power negative 1, then inverse function of 1 over x, that is x over x to the power negative 1. Okay, so where do you here? is equals to negative 1 times x to the power negative 1 minus 1, then dx. So where du here, that is equals to negative x to the power negative 2 dx. And then dx here, that is equals to du over negative x to the power negative 2, or where dx here, that is equivalent of negative x squared du. Okay, so take note the inverse function of 1 over x to the power negative 2, that is x squared. Okay, so that we can obtain the equivalent of dx, which is negative x squared du. Then we can change the given, and so that we can integrate. So the integral of e to the power u. So I change this into u, which is 1 over x. So where dx here, that is negative x squared du over x squared. Okay, so we can now cancel out x squared here. So we have negative the integral of e to the power u, then du. Okay, so negative e to the power u, then plus c. Okay, substitute the value of u. So we have e to the power 1 over x plus c. Okay, so that is the final answer. So next, what is the equivalent antiderivative of x squared e to the power negative x cubed? Okay, so I let you here, which is a negative x cubed. Okay, times dx. So where u, that is equivalent of x cubed, then where du here, that is equals to negative 3x squared, then dx. So where dx here, that is equals to du over negative 3x squared. Okay, then okay, so we change the problem given, and then we integrate. So that is equals to the integral of x squared a to the power u, then dx here, that is du over negative 3x squared. Okay, and now we can cancel out the x squared. Then we have negative 1/3. Okay, then the integral of e to the power u du, then that is equals to, okay, so we can now integrate this. So we have 1/3 e to the power u, then plus c, or we have negative 1/3 e to the power u plus c. Then we can now substitute the value of, or the equivalent of u, so which is negative x cubed. Okay, so negative 1/3 e to the power negative x cubed, no? Then plus c. So that is the final answer. Next, what is the antiderivative of e to the x square root of e to the x plus 2 dx? Okay, by the way, I let you here, which is e to the x plus 2. Okay, So du here, that is equals to ex dx. So we have dx here, that is equals to du over e to the power x. Okay. From the problem given, we have integral of e to the power x. Then I change e to the x plus 2, which is our u. So we have the square root of u. Then we have dx, that is equivalent to du over e to the power x. Then we can now cancel e to the power x. And then we have the integral of square root of u, or u to the power 1/2. Okay. 1/2 du. Okay. So therefore we have u to the power 1/2, okay, plus 1 over 1/2 plus 1, then plus c. Okay. So we have u to the power 3 over 2, then over 3 over 2, then plus c, or 2/3 u to the power 3 over 2, then plus c. Then substitute the equivalent u, which is e to the power x plus 2. Okay, so we have 2/3 e to the power x plus 2, or the quantity of e to the power x plus 2 to the power 3 over 2, then plus c. Or we finalize the answer, which is 2/3 the square root of quantity of e to the power x, then plus 2 to the power 3, no? Then plus c. So that is the final answer. Okay. So next, problem number 5. What is the equivalent integral or antiderivative of the quantity of e to the power x plus 1 to the power 2, no, over e to the power 2x dx? Okay. So take note that e to the power x plus 1 n times e to the power x plus 1. Okay. So we can now multiply e to the power x times e to the power x, that is equals to e to the power 2x, then plus e to the power x, then plus e to the power x, then plus 1. Okay. So we have e to the power 2x plus 2 e to the power x, then plus 1. Okay. We can now substitute. So we have the integral of e to the power 2x, then plus 2 e to the power x, then plus 1, okay, over e to the power 2x. Okay. So we have quantity in dx. Then we can now divide or individually, no? So we have quantity of e to the power 2x over e to the power 2x, then plus 2 e to the power x over e to the power 2x, okay, then plus 1 e to the power 2x, then dx here. So therefore, that is equals to the integral of this can be cancelled. Okay, so 1, then plus d2 e to the power x over e to the power 2x. So that is 2 e to the power negative x. Okay, so plus e to the power negative 2x, then dx. Okay, so we can now integrate the integral of 1, that is x, and plus 2, the integral of e to the power negative x, that is equals to negative e to the power negative x. Okay, then plus, so take note, we integrate the e to the power negative 2x dx. Okay. So therefore, our u here is negative 2x. Then our du here, that is negative 2 dx. So where dx here, that is equals to du over negative 2. Okay, so this can be the integral of e to the power u, then times du over negative 2. No? So again, dx is equals to negative du over 2. So we have negative 1/2 integral of e to the power u du. Okay. So that is equals to the negative 1/2 e to the power u, then plus c. Okay, so therefore here, that is negative 1/2 in e to the power negative 2x, then plus c. So we have x minus 2 e to the power negative x, then minus 1/2 e to the power negative 2x, then plus c. Okay. Then the final answer is x minus 2 e to the power negative x minus 1/2 e to the power negative 2x plus c. So that is the final answer.